Okay, we'll look at some more examples then involving tangents and normals, and these would be typical exam questions then. So find where the tangent to the curve y equals 5x squared minus 6x plus 1 is parallel to the line x plus y equals 4. So when it says find where, that's looking for the point. So your answer is going to be coordinates. Okay? So it's parallel to this line. So let's look at this line, x plus y equals 4, and let's rearrange it into our form y equals mx plus c. So we can see that the gradient of the line is minus 1. So we want to find where the gradient of the tangent is also minus 1. Remember, parallel means that they have the same gradient. So we've looked at this part. Now we need to look at the tangent then to this curve. So we know that tangent to the curve you find by differentiating. So dy by dx then gives us 10x minus 6. And we want to find the x value that makes this gradient of this tangent minus 1. So minus 1 equals 10x minus 6. Bring your minus 6 across. So we get 5 equals 10x, so x equals a half. Now we want to find our y value, and this is where sometimes people put it into the wrong equation. We want to find the y coordinate on this curve where this tangent has a gradient of minus 1. So we say that y equals 5 times, we put our x value in here. So it's y equals 5 times a half squared minus 6 times a half plus 1. So it's 5 times a quarter minus 3 plus 1. And that turns out to be minus 3/4. So our answer then has to be, remember we've said we were looking for a point, so our answer had to be coordinates. So our x coordinate is a half, and our y coordinate is minus 3/4. Okay, our second one. Find where the tangent to the curve y equals 5x minus x squared plus 4 is perpendicular to the straight line joining the points minus 2, 3 and 3, 2. Okay, so you have a lot of information here. So again, it's asking us find where, so we're looking for coordinates as our answer. Okay, now we want the tangent to this curve to be perpendicular to the line joining these points. So the first thing we need to do is find the gradient of the line joining minus 2, 3 and 3, 2. So use our formula then. Our gradient m is y2 minus y1 over x2 minus x1. So our second y coordinate is 2 and our first one is 3. Second x coordinate is 3 and our first one is minus 2, so be careful, it's minus 2, so that's plus 2. So it's 2 take away 3, which is minus 1, over 3 plus 2, which is 5. So that's the gradient of this line. So we want the gradient which is perpendicular to that line. So that's going to be 5. Okay, so we found the gradient of this line is minus a fifth, so the gradient of something perpendicular to the line would be 5. So the question then is we want to find where the tangent to this curve has a gradient of 5. So now we're going to need to find dy by dx and set it equal to 5. So dy by dx is 5 minus 2x, and we want to find the x value that makes it 5. And we find that the x value is 0, and then the y value is going to be 5 times 0 minus 0 plus 4, so that's 4. So our answer will be the point 0.4. Okay, so our third one then. Find the coordinates of the points where the tangent to the curve y equals 4x cubed minus 15x squared minus 60x plus 2 is parallel to the straight line y equals 4 plus 12x. Okay, so the first thing, the question has said that we're looking for coordinates, but it's of the points plural, so there's going to be more than one set of coordinates in our final answer. So we want where the tangent is parallel to this straight line. So the gradient of this line equals 12. So we want the points where the tangents to this curve have a gradient of 12. And remember now, this is a cubic, so it looks something like that. So there could be 2 points where you have tangents that both have a gradient of 12. Okay, so we need to do dy by dx. So we get 12x squared minus 30x minus 60. And we want the x values that'll make this whole thing equal to 12. So we should notice now that we've got a quadratic that we'll have to solve. So remember, to solve a quadratic, it has to equal 0. I'm going to make it a wee bit easier just by dividing by 6. And we get 2x squared minus 5x minus 12 equals 0, which is the quadratic that we'll have to solve. Now it factorizes to give us 2x plus 3 upon x minus 4, which gives us x values of minus 3 over 2 and 4. And you would expect two answers, because again, remember we said we were looking for 2 points. Okay, so these are our x coordinates, and now we need to put them in to find our y coordinates. So when x equals minus 3 over 2, y is going to be 4 times minus 3 over 2 cubed minus 15 times minus 3 over 2 squared minus 60 times minus 3 over 2 plus 2. And when you work all that out, that gives you 179 over 4. So that's our first set of coordinates. And when x then equals 4, y is going to be 4 times 4 cubed minus 15 times 4 squared minus 60 times 4 plus 2. And that gives you minus 222. So our two answers, minus 3 over 2, 179 over 4, and 4 minus 222.